Alright, and we're going to continue now with the last part of our working example, which was on the respiratory syncytial virus. And now we're going to assume that we're going to put the entire Twin Cities metro area under a quarantine. And so the goal here is to either significantly slow or stop the spread of the disease. Okay, so really what we want to look for the case when I prime is less than or equal to 0, because that means that the disease is that the spread of the disease is slowing, and it is the rate of change in the infected compartment is negative, meaning that the infected population is decreasing. Okay, so suppose that the quarantine put into effect on day 0 reduce the chance of contracting the disease by a factor of 20. Okay, so remember, in our scenario, our transmission coefficient is this number. Our recovery coefficient is this problem. So what I want to look at here is I want to look at I prime. Okay, so I prime, remember, this is equal to ASI minus BI. Okay, so A changes, okay, reduces the chance of contracting the disease by a factor of 20. So what this means is that A is no longer this. The chance of transmission is decreased by a factor of 20, meaning it's 1/20th as much. So meaning, if I do the computation, A should now be 0 and then 6 zeros divided by 20. And if you do this, you get 0 and then 8 zeros, 2 or 3, 4, 5, 6, 7, 8, and then an 8 after all that. Okay, so computing I prime now, I'm going to use this new transmission coefficient. So I have 0. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. 8 times my S population, which was the 3,230,000. Okay, times the I population, which is 50,000, minus B doesn't change. The recovery rate does not change with a quarantine. So you still recover at 0.1 or one person every 10 days. So 0.1 times 50,000. Okay, and if you do this computation, you get -3708. Okay, so is this less than or equal to 0? And the answer is yes. Okay, so yes, it was effective, and the disease is slowing down. So yes, it was effective. Okay, now just a bonus question, how does the threshold change? Okay, so remember, threshold is defined to be B over A. Okay, and I added some subscripts just for us to clarify. Now remember that the new recovery rate, B, didn't change. Whenever you put a quarantine into effect, the recovery rate does not change. When you put a quarantine into effect, though, the transmission coefficient changes, and that was 1/20th of this. So I can do, instead of putting in the number, I'm not going to use numbers, I'm going to say this is now A divided by 20. Okay, meaning that if I rearrange this, I'm going to write this as 20B over A. Okay, and pulling this apart even more, I can break this up into 20 times B over A. Okay, now B over A, this was the old threshold. Okay, so what I'm saying is that if you decrease if you decrease the transmission coefficient by a factor, say 20, what it ends up doing to the threshold is it increases the threshold by a factor of 20. Okay, so there's a reciprocal relation that you need to pay attention to. Okay, and so this is the end of the example, and you should be able to work on the worksheets and complete them successfully.